Section R4 is about polynomials. Polynomials are functions of the form, some constant times x to the n plus another constant times x to the n minus 1 plus dot 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 plus, something times x to the 1 plus another constant, where n is some non-negative integer. So it's sums of constants times powers of x, where the exponents are positive integers or 0. There's a few things about polynomials everybody should know. Most people can FOIL out a plus b when they see it, but I think it's very important to know exactly what a plus b squared turns out to be without having to FOIL it out as if you've never seen this before. It's going to be a squared plus 2ab plus b squared. In words, a plus b squared it's the first thing squared and the last thing squared and 2 times their product. And a minus b squared is a squared minus 2ab plus b squared. If you have to FOIL out a plus b squared to remember this, you're wasting time on the exams. And there's going to be times in problems when it really pays to recognize that that's a perfect square, and it only comes from knowing this formula. Here's another thing everybody has to know. You should know without having to FOIL it out, that a plus b times a minus b is the same thing as a squared minus b squared. There are lots of times in problems that we have the left side is given to us and we have to recognize that it's the same as that or vice versa, and it pays to just remember the formula. There's a formula for, this is called a square minus a square. There's a formula for cube minus a cube, and it looks like this. So a cubed minus b cubed is a minus b times, a squared plus ab plus b squared. I remember that it looks kind of like a plus b squared, but it's not. The coefficient of ab here is 1 instead of 2 up in the square formula. And there's a formula for a plus b, or rather a cubed plus b cubed. It's a plus b times a squared minus ab plus b squared. There are also formulas for a plus b cubed and a minus b cubed and higher up, but the truth is it doesn't really show up in the homework. It's kind of beyond this class, I guess. But everybody should have these guys memorized. I just want to give you a tip about multiplying polynomials. Let's suppose in an example they want me to multiply, say, 2x cubed minus 7x squared plus x minus 3 times x squared plus 4x plus 2. To multiply out two polynomials means that every item in the first set of parentheses has to eventually multiply every item in the second set of parentheses. So this 2x cubed has to multiply x squared, it has to multiply 4x and 2. So I'm going to carefully multiply the first thing here times these 3, and then the second times each of these 3, then the third and the fourth. It pays to maintain columns. So 2x cubed times x squared plus 2x cubed times 4x plus 2x cubed times 2, etc. Before I write it all down, I want to notice that x cubed times x squared, they have the same base, so there's a law of exponents that says I can just add the exponents. So I'll start again and say that when the first thing here hits the first thing there, I get 2x to the fifth. And this is, order in which we multiply things doesn't matter. So this is the same thing as 2 times 4, which is 8, times x to the, I've got 3 x's here and another one there. Altogether, that's 4 x's in a row. And this is 4x cubed. Now I'm going to do a line break and multiply the negative 7x squared times each of these guys. So notice every time I multiply negative 7x squared times each of these guys as exponents get increased by 2 because I'm multiplying by x squared and exponents add. So when the negative 7x squared hits that, I'll get negative 7x to the fourth. I'm going to put that in the same column as the earlier x to the fourth I had, the 8x to the fourth. And the negative 7x squared times 4x will be minus 28x, well, x squared times x to the 1 is x cubed. And negative 7x squared times positive 2 is negative 14x squared. Okay, now the x has got each of these guys. I'm going to do a line return because once I start taking x times each of these, I'll see some of the same powers I did before. So x times x squared is x cubed. X times 4x is plus 4x squared. X times 2 is 2x. I think I just have room for this. Negative 3 times each of these will be negative 3x squared minus 12x minus 6. It really helps me when I've got all these powers of x in the same place, in columns according to powers. That is, I've arranged all these terms in columns according to the powers of x I see. So now that's just 2x to the fifth. 8 of these minus 7 are the same thing as plus 1x to the fourth. And I guess this is 5 minus 28 is negative 23x cubed. Looks like negative 13x squared minus 10x minus 6. If you can multiply polynomials, then you can divide them. So let's go through an example of long division with polynomials. Let's say I want to divide 2x to the fourth plus 3x cubed plus 8x squared plus 10. I want to divide all of that by x squared plus 2x plus 3. So I'm going to take this 2x to the fourth stuff and put it under this division sign. It's really important to maintain separate columns for the powers of x I see. Fourth, then come the x cubes and the 8x squareds. And I notice there's no x to the 1 column in here, so I'm going to just put one in, 0x to the 1. And the 10 belong in the constant column, the x to the 0 column. And that's going to be divided by x squared plus 2x plus 3. So when I write it this way, I've got one column for each of the powers of x that appear in my polynomial. That's the same way that we write numbers written in base 10. We have separate columns for all these different powers of 10 I see. Long division, I think it's interesting, long division with polynomials is a lot like long division with numbers written base 10, and we've just got powers of x's instead of powers of 10. So the step that I take with polynomials is always the same. I ask myself, what do I have to multiply this highest power and its coefficient by, this leading term here, in order to get that leading term? What do I have to multiply x squared by in order to get 2x to the fourth? Well, the answer is 2x squared. So it goes up here in the x squared column. It becomes part of my quotient. That's the polynomial that will appear on the top when we're done. So 2x squared times that would be this. Let's multiply 2x squared times all three terms and maintain separate columns. So 2x squared times this is 2x to the fourth, and 2x squared times 2x would be 4x cubed, and 2x squared times 3 would be 6x squared. Now, just like in regular long division, now what I want to do is subtract all of that from this original polynomial. And when I do, the x to the fourth term drops out. So that's 3x squared minus, or rather 3x to the third minus 4x to the third is minus x to the third. And 8 minus 6 is positive 2x squared, and 0x to the 1 plus 10. So I do this step again. What do I multiply x squared by in order to get negative x cubed? And the answer is negative x. So I put negative x up in the x column in the quotient. Negative x now times all of that stuff. And then subtract that from this. And the x cubed terms should drop out, and they do. So I've got 2x squared minus a negative 2x squared is positive 4x squared. And it looks like positive 3x and plus 10. So I keep trying this one basic step. What do I multiply x squared by in order to get 4x squared? And the answer is 4. So let's multiply 4 times all of that. I'll get 4x squared plus 8x plus 12. And I'll subtract that, and the x squared terms drop out. 3x minus 8x is negative 5x, and 10 minus 12 is negative 2. Negative 2. Now if I try this step again, what do I multiply x squared by in order to get negative 5x? You can see there's no positive power of x that I can multiply x squared by to get that. I could multiply x squared times something to get negative 5x. It's negative 5x to the negative 1. But that's not a polynomial. Negative powers of x aren't allowed in polynomials. If you kept going with the long division using negative powers of x, that's kind of like in long division with numbers in decimal form, when you continue to have numbers, after the decimal point to stand for those negative powers of 10. But in polynomial long division, we stop when the degree here is less than the degree there. I know from experience too that I must have been done here because the last thing I added to the quotient was a constant. There are no other columns left. So this guy up here is the quotient. And this bit down here is the remainder. What we just discovered is that, just like with decimal numbers, that 2x to the 4th plus 3x cubed plus 8x squared plus 10 divided by x squared plus 2x plus 3, well, that's 2x squared minus x plus 4 with remainder negative 5x minus 2. That remainder really means something. Think about it. If you had, say, 17 divided by 3, you'd say that's 5. You'd say that's 5 with remainder 2. But what's that mean? It means 17 thirds is 5 and 2 thirds. So what we discovered about this polynomial is 2x to the 4th plus 3x cubed plus 8x squared plus 10 divided by x squared plus 2x plus 3 is, let's see, that quotient was 2x squared minus x plus 4. And the remainder is the stuff that's still being divided by the x squared plus 2x plus 3.